Hey Geometry, today we are going to preview the distance formula and try to understand where it came from and what it means. So if we want to just think about the distance formula, first we have to think about what distance is. And distance is really simple. It's just the number of units between 2 points or two objects. In this case of a grid here, when two objects are horizontal, we can just count the number of grid marks between them. 1, 2, 3, 4, 5, 6, 7, 8. And so that would mean the distance here would be 8. Well, mathematically, we have better ways of doing that. Instead of just counting each grid mark, we can simply take the x value of one point and subtract the x value of another when they're horizontal like this. That's why we consider a distance between two horizontal points as just x sub 2 minus x sub 1, the second x value subtracted by the first x value. And so this would still give us the same answer, 12 minus 4 would be 8. We can do this same mathematical approach by two vertical points. The distance from them can just be found by subtracting the second y value by the first y value. So in this case, 7 minus 1 would be 6, which is easier than just counting the grids. But what about if we have two diagonal points like this? We can't simply count up the grid marks between the 2 points because that's not how a grid works. A grid only works horizontally or vertically. And so in this case, we would need to use the distance formula. And this may look a little confusing, but it comes from a place that we are already familiar with. And so if I think of 2 points that are diagonal from one another as two vertices of a right triangle, this actually helps me understand the distance formula. Because the first coordinate, we'll just call it x sub 1, y sub 1. And then the second coordinate, we'll call it x sub 2, y sub 2. And so since we can use the Pythagorean theorem to solve for the hypotenuse of any right triangle, we can treat this the same way. Our Pythagorean theorem up here, a squared plus b squared equals c squared, means I need to plug in the lengths of both legs of my right triangle in order to solve for the hypotenuse of my right triangle. And in this case, my horizontal distance is just x sub 2 minus x sub 1, and we can plug that into our Pythagorean theorem here. The same thing happens for my vertical leg. I can plug that distance into my Pythagorean theorem into where the b squared is. And so now I take this equation I have at the bottom here, and I can finish solving for the distance of that hypotenuse by just square rooting each side, which gives me this. And this is the distance formula, the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And so this is my distance formula, and a right triangle is conceptually how we found the distance formula. So in class, we are going to practice the skill of applying the distance formula to find the distance between two objects on a coordinate plane.